There are two major reasons that we might not wish to solve a rational equation as a proportion. The first one, of course, is that it requires that we add together any rational expressions that we see on both sides. As we saw, in order to solve it as a proportion, it needs to be a proportion, an equation stating that two fractions are equal. But there's another reason, too. The second reason is that we risk introducing extra extraneous solutions. Let me show you an example of this. Let's suppose we want to solve this rational equation. This is a proportion, and so if we really want to, we can solve it as such. Our cross products will be x times 3x minus 2 equals 1 times 2 minus 3x. So simplifying, 3x squared minus 2x equals 2 minus 3x. This is a polynomial equation, so we need to get all of the terms on the same side. Add 3x on both sides, subtract 2 on both sides, and we'll get 3x squared plus x minus 2 equals 0. We'll need to factor, splitting up the middle term using two numbers whose product is -6 and whose sum is +1. +3 and -2 should do. Let's see, factoring out the greatest common factor, here we'll have a 3x and a -2. Here we'll have an x and a 1. So, in factored form, 3x minus 2, x plus 1 equals 0. Oh, but we notice that in cross-multiplying, we multiplied by both of these denominators. In cross-multiplying, we introduced this extraneous solution. Only x equals -1 is a true solution. By cross-multiplying, we introduced an extraneous solution that we really didn't need to have there. And in fact, we did something even worse than that to ourselves, as we'll see when we use the other method. What's the alternative? The alternative is to multiply both sides by the LCD. This still risks introducing extraneous solutions, but it's less likely. Let's see how that works in this case before we break down the process. Looking at these two expressions, I notice that 2 minus 3x is the opposite of 3x minus 2. And so, my LCD is just 3x minus 2. I'll multiply both sides of my equation by 3x minus 2. Since there's no addition, this is pretty straightforward. Here, we'll cancel out the 3x minus 2. Likewise here, and I'll get x over -1 equals 1. Multiplying both sides by -1, I get x equals -1. What do I want you to notice here? We didn't need to solve a polynomial equation. By only multiplying by the denominator once, I was able to give myself an easier equation to solve and avoid introducing an extraneous solution. The third reason we might not want to cross-multiply, we risk higher degree polynomials. In the next video, we're actually going to break down the process of how to solve a rational equation in this way.